Hello, welcome to lesson 9 on the topic Permutation and Combination. If you remember, in lesson 8 we were discussing some applications, very interesting applications of permutation. The last example that we had discussed, I would like to start from there and present that same question in a different way. Alright, so if all of you are listening carefully, suppose we have 8 different English books and 4 Hindi books. The Hindi books are also different, I'm sorry. So 8 different English books and 4 different Hindi books to be arranged on a shelf. So we are talking about a linear arrangement. Now what is the question? No two Hindi books are together. No two Hindi books are together. The same concept that we had discussed towards the end of lesson 8. Okay, how will we do this? What did we discuss in lesson 8? The first thing that we'll do is we'll first arrange the English books. Now 8 different English books, 3, 4 and then 5, 6, 7 and 8. 8 different English books can be arranged in 8 factorial ways. Correct? 8 different English books can be arranged in 8 factorial ways. How many places created for the Hindi books? So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 places created for the Hindi books. How many Hindi books are there? 4 different Hindi books. So the 4 different Hindi books can occupy any 4 of these 9 places. So the first book can occupy a place in 9 ways, the second in 8 ways, the third in 7 ways, the fourth in 6 ways. So what is my final answer? 8 factorial multiplied by 9 into 8 into 7 into 6. Can I present this answer in some other way? Absolutely. I can write it as 8 factorial into 9p4. Because 9p4 is 9 into 8 into 7 into 6. So, in how many ways can 8 different English books and 4 different Hindi books be arranged on a shelf such that no two Hindi books are together? 8 factorial into 9p4. Right? All the other parts that we had discussed, by taking the example of 5 boys and 5 girls, all those can be taken and brought to this particular example, can be done, can be practiced to understand this better. Alright? Okay. Now, so far we have been talking about, when we have discussed permutation, we have been talking about people or things. The concept of permutation can be put to a very important use when we talk about formation of numbers using digits. Okay, formation of numbers using digits. Let me begin by sharing something that you are already aware of. Okay, let me ask you this question. How many 3-digit numbers are there? How many 3-digit numbers are there? Alright. One answer that usually we get from students is that when we talk about a 3-digit number, 100 is the smallest, 999 is the largest. Okay, 100 is the smallest 3-digit number, 999 is the largest 3-digit number. Therefore, number of numbers will be 999 minus 100 plus 1. I hope you know this. This is the number system approach. Okay, the smallest is 100, The largest is 999, and therefore the number of numbers is 999 minus 100 plus 1. So students will invariably be able to answer this question as 900. There are 900 three-digit numbers. I take it a step further and ask them, can you explain this using some other way? So this is the number system approach. Is there some other way to explain why there are 900 three-digit numbers? Oh, please listen to this. What are we talking about? We are talking about 3 chairs or 3 places, right? And who is going to occupy these 3 places? These 3 places are to be occupied by 10 digits called 0 to 9. So remember the first example where we were talking about a teacher inviting 7 students. So there are 10 digits called 0 to 9. There are 3 places. There is something additional that you have to consider here. And what is that? A thing or a student or a person cannot occupy more than 1 place. But what about these digits? They can, if they want, occupy more than 1 place. That means in case of digits, repetition may or may not happen. I repeat, in case of digits, while forming numbers, repetition may or may not happen. So let's come back. Okay, another very important thing. One of these 10 digits called as 0 can never occupy the first place from the left hand side. I repeat, one of these digits called 0 can never occupy the first place from the left hand side. Why is it so? Otherwise this number will not be a 3-digit number, it will become a 2-digit number. Okay, now let's come back. So this place can be occupied in 9 ways. Any digit from 1 to 9, and this place, because repetition is allowed, this place can be occupied in 10 ways. What about the third chair? The third chair can also be occupied in 10 ways. So what is the total number of ways in which these 3 places can be filled? It is 9 into 10 into 10. What is 9 into 10 into 10? 9 into 10 into 10 is 900. That is the reason, that is the explanation of why we have 900 different 3-digit numbers. Okay. Now when we talk about application of this concept, from the point of view of competitive exams or placement papers, this becomes very important, because very frequently you will be asked questions that are to be solved using the concept of formation of numbers using digits, and that is where all of us have to be absolutely thorough with this concept. But before we move on, let me tell you a few things that you have to take care always. Okay, when we talk about formation of numbers using digits, right, when we talk about formation of numbers using digits, there are 3 rules that you must keep in mind. 3 rules. Okay, 3 important rules. What are they? First, check if repetition is allowed or not. The question will clearly tell you whether repetition of digits is being allowed or not. So what is the first rule? First important rule. Check if repetition is allowed or not. Okay. What is the second rule? 0 as a digit can never occupy the first place from the left. Okay, Very important. 0 as a digit can never occupy the first place from the left. Very important. And the third, therefore, whenever, now this is very important, therefore whenever 0 or any digit behaving like 0 alright, this is going to be interesting. So therefore whenever 0 or any digit behaving like 0 is also a part of the main condition, that case has to be separately treated. I'm sorry, yeah. So what is the third point? Whenever 0 or any digit behaving like 0 is also a part of the main condition, mind you, whenever it is also a part of the main condition, that particular case has to be separately treated. The most important learning, failing which students invariably make mistakes in getting the answer to such questions, because they make a mistake in point number 3. Whenever 0 or any digit behaving like 0 is also a part of the main condition, that case has to be separately treated, separately solved. What does it actually mean? We will look at this in the subsequent lessons. Thank you.